unwanted traffic does not always come on TCP port 25. So we decided at ISC that we would try to repeat the experiment, except this time we were going to do it with DNS rather than with email server IP addresses. So, because I've been sued out of existence once, we decided early on we're not going to produce content for this format. In other words, if somebody is out there and they're registering names and those names are malicious according to somebody, and there's a market for information that would somehow list those domains as being bad, and the act of listing those names as bad would then cause the registrants of those names to lose money. I will not be the one who gets sued. And I like that part. But we are going to create a universal standard for the interchange of information about domain name reputation, so that whether you're an enterprise, ISP, wherever you are, if you want to subscribe to this, it's going to be highly likely that the recursive DNS server that you're going to use as your subscribing element will speak this protocol, will understand this format. And we anticipate that just as with the RBL, there will be hundreds of different companies offering reputation data in this format. So, again, I want to emphasize we know we did two things with the original RBL. We're only doing one of them here. Now, of course, this technology already exists in a couple of proprietary products. Those people have had sometimes a little trouble getting started in the market because when you're selling DNS firewall filters, essentially, and you tell some really large ISP, yeah, this will work fine, but you have to use a different recursive name server than the one you're using today. You have to switch to our technology. And by the way, we're a security company. We are not a DNS company. This is not our primary line of business. But we want you to trust us. We think recursive DNS is a simple problem, and we solved it. And so if you just replace bind or non or whatever it is you have now with our custom internal solution, then you'll get this wonderful DNS firewalling capability. Most ISPs will look at you like you're nuts because they've already spent several years qualifying the stuff they're running now in some test lab. So I treated this as an unsolved problem, even though there was a lot of invention to go on. We had to determine and to answer some questions and propose a format, but I knew that some other people were already doing this. Nevertheless, to make sure it would be a universal standard, I have avoided any existing known patents or other encumbrance. Not that a U.S. patent is worth a whole lot on the world market, but I wanted to make sure that as people started to deploy this, they would not suddenly get a letter from somebody somewhere saying that we're going to commercialize this, you owe us money. Now, those of you who lived through the spam wars in the 90s may remember that if you subscribed to an RBL, you would send a DNS query, usually to me, asking about the reputation of each potential mail sender that would come to your mail servers. And that was a lot of wide array DNS traffic. And let me tell you, if you think it was a lot for you, you should have seen what it looked like at the bottom of the funnel where I was receiving it all. We're not going to do that again. And one of the reasons is this is happening inside of a DNS server. And there's just no way that you could, while deciding how to answer a single DNS query, generate 5 others every time. That's too much load. So this only works with transfer access. We're still using DNS to produce and consume this data, but we're only doing it on zone transfers. And one of my other constraints was I didn't want to become an info spammer in my own right. There are plenty of companies out there who, if you make a typographic error in a web browser, will, instead of sending you an error message, they will send you an ad. They will send you, well, I think since you didn't type anything that existed, I'm going to give you something that's close to what you typed and hope that you're going to buy it. And I hate that. So I wanted to make sure that while we were doing this, we didn't accidentally make that easier. So we didn't. I told you I was going to skip some of this. I'll be here through the conference. So if anybody wants to talk details or even see demos, I'm happy to participate in that. But I'm not going to go through this unless it comes up in Q&A. This is what it looks like. The bottom of this screen shows some additional stuff that goes on in Bind version 9. If I've patched it to have this functionality. Right now it's only a patch. We have not incorporated this into the official Bind release yet because we're still playing with it. But it's fairly simple. You just say, I'm going to subscribe to a couple of the policy zones. These are their names, and these are the order I want you to be testing them in. Inside those zones, we've got, basically we use the owner name as the pattern to trigger. So we can say, if the query name matches the owner, then do the policy that has been encoded in this weird looking CNAME. Right, a CNAME to the root, to dot, see here is useless. You'll never see that in nature. So we used it to encode an NX domain policy. So if you look up this name on a name server that's got a policy zone that sort of contains this record in it, you'll get an NX domain instead of getting real data. And it's just that simple. You can also force various other things. I'm not going to go through those in great detail. Most of the time, if you're afraid that you have infected computers that are going to try to contact a command and control server, NX domain is fine for you. But you might prefer to send your subscribers to a walled garden, which is similar in some ways to sending them an ad. And that possibility exists here. More details that I'm going to skip. Okay. Here's maybe something interesting. A lot of times what is known to be bad is not a domain name. And so when we first announced this technology, a lot of people who were either already doing this in some proprietary way, or they were interested in doing this and they had some kind of reputation data. A lot of security companies have a lot of reputation data, and they were thinking, hey, this would be a great channel, but how do I describe this and that and the other? The biggest simple thing is, if they don't know what domain name it's going to be, but they're absolutely certain that a given IP address would be bad, they'd love to be able to put the IP address into the policy zone so that we can trigger on that. We're working on this now. It's going to look a little bit like what's on the screen. And some of the details here are so ugly that not even a mother could love them. But when you're working with DNS as a way to encode things, you often have to bend over backward to make things fit. But the idea here, let's imagine this is my home network. If you had a policy zone that contained a record like that, then it would, if the server, after it had searched the cache and done the recursion and fetched the data and it was assembling the response, so this is not so much happening at query time as our name-based patterns do, but it was happening at response time. If any of the A records that are about to go into the response are in that CIDR block, then it would trigger the pattern. And that way, if you're not sure what name the bad guys are going to use next, but you know that it has to be in a certain CIDR range because that's the one they're pirating right now, you will still be able to use RPZ as a way to affect DNS response policy. Now there are similar types of things for IP version 6, and let me just say, as the chairman of the American Registry for Internet Numbers, you should all be using IPv6. Very important. We're going to run out of v4. Anyway, so we made sure v6 would work right away. We also have the ability to poison name server addresses, because often one of these snowshoe spammer attacks will include